Let me welcome you to the 56th lecture of NPTEL online certification course Drilling and Blasting Technology. We are discussing about the special blasting techniques. This is the fifth topic in the special blasting techniques, and this is the second lecture on demolition of structure by blasting. We have already covered the first lecture, in which we have discussed how the demolition is being decided for a structure and how the mechanical means can be adopted to demolish a structure. So, we have already understood the necessity of the demolition of the structures. We have also understood the merits and demerits of the demolition blastings. Now, let us start how the different elements has to be blasted. So, we understood the basic principle of demolition of blasting is that we have to basically disintegrate the elements of a structure. If the elements of a structure, that means foundation, walls, pillars, slab, roofs, beams, if these elements will be disintegrated, that means their joints will be removed, they will become standing alone, then they will be gravitated down by their weight and become demolished. So, the basic principle is that we have to inject or we have to include the instability in the structure. That instability in the structure basically redistribute the load, and as the load will be redistributed, all the disjointed elements will fall down by its gravity and the building will be demolished. So, let us start with the understanding of the demolition. We have basically classified our elements as foundation, wall, pillar, slabs and beams. Basically, these are the elements we are considering, and we will try to understand how these elements will be blasted and this will be disintegrated for the demolition. So, our first is that foundation. So, basically the figure we have shown, basically this part is the foundation which is below the ground. So, in this foundation we have to basically blast it. So, it is basically as simple as bench blasting, which we have discussed in the surface mining case. So, this is similar to the bench blasting, where the foundation has to be drilled with the vertical holes, and then we have to blast it. Now, the drilling length of these vertical holes will depend on the size of the foundation, that is the depth of the foundation. Generally, we carry out our drilling up to a such depth, so that it will not move out of the foundation. So, the furthest end of the drill hole should be within the foundation, and the bench blasting, as the way we are loading the charges, that is the quantity of the charge, will be placed considering the similar bench blasting concept. Generally, on a say a thumb rule, what we consider, the 2/3 has to be charged, 1/3 has to be stemmed. So, basically similar concept we can consider, but this quantity will basically depending on the material quality. The type of the foundation, whether it is reinforced or not reinforced, the age of the material, those are the important requirement that has to be considered while this charging has been decided. So, Gimeno et al. Has given this table considering the non-reinforced concrete of poor quality. Concrete of poor quality means it is that old one, it is not very new one, and its material quality has been deteriorated significantly. Second one is that non-reinforced concrete of good quality. We may have brick also. So, these are basically either a block concrete or a brick one that has to be blasted. Next is that the reinforced concrete, generally that is practiced in most of the cases of the modern buildings where the foundations are reinforced concrete, and where the light reinforcement is there, that is one consideration. Second is that the where heavy reinforcement is provided, and for very big considerations where the military type buildings are there, that means for the constructions where bunkers are made, military bunkers etc., so that explosion proof structure can be made. On those cases the we have to consider the high powder factor. So, this is the powder factor and the drilling depths are given. This is given in the book of Gimeno, that is directly presented here. So, this is one guideline, but one must understand that considerations of the powder factor, considerations of the depth of hole is very site specific. The decision has to be taken by the expert blasting engineers while that is being executed. So, that is the essential requirement, and generally for all the cases square patterns are used, that means burden is kept is same as the spacings. So, the next element we consider is the wall. We are having basically three types of wall. One is that the brick wall, where bricks are used, where concrete walls are also there which are not basically stressed, and we may have concrete load bearing walls also which is having load on this. So, basically our current structures which are being made of the pillars and beams, the walls which are placed between these two rooms and etc., those are basically walls without stress. The stress is basically taken by the pillars and the beams, not by the walls, but sometimes we may have load bearing walls also which is taking the loads, basically the river embankment etc., where the loads are load bearing walls are placed. So, if it is a brick wall etc., the drilling has to be carried out. For all the cases in a wall, basically drillings are carried out, horizontally. So, these horizontal drillings are made, and in this horizontal drilling the charge is placed. So, here also one need to take care that this length of drill should not cross the width of the wall. So, that the hole must be controlled within the wall, it should not move out of the wall. So, there must be some place, some additional gap has to be kept in the bottom part of the hole. So, that is why the guideline is basically says this length should be equal to the 2/3 of this one. So, if this is HM and this is L, then L is equal to 2/3 of HM, that means the width of the wall. So, that must be considered while the blasting is carried out to demolish the wall. The quantity of explosive again is depending on the type of material, size of the wall, consistency, that means whether the door is there or not, window is there or not. If that is there, then that part has to be considered, and whether there are nearby inhabitances or there, that has to be controlled. In that case, we basically reduce the charge quantity, we allow a large size fragmentations, and we opt for not flying of those objects. So, we just basically increasing the burden and spacing, opting for a lower quantity of charge, and we allow the large piece of boulders, and that can be handled separately. So, in those cases those considerations are made, and based on that the total charge quantity has to be decided. This is one guideline is given by Gimeno et al. Considering the wall thickness, and all the cases the burden is equal to, considered as the burden is equal to spacing considering the square pattern, and the number of holes has to be decided considering the length of the wall. So, that is the requirement, and again the charge quantity has to be decided, but stemming must be sufficient, stemming must be provided, so that the risk of fly rock can be avoided. In second case, for concrete walls, basically we may have reinforced wall, we may not have a reinforced wall. For both the cases we have to, the basic principle is same. In basic principle we have to consider the length of hole as same as the previous one, 2/3 of the thickness of the wall, but the charge quantity that is the requirement has to be considered based on the type of material, size of wall and consistency. So, here it is, see, you can see the basically the charge quantity is considered little bit higher for both the cases, stressed wall or with load bearing wall or non load bearing wall. For both the cases the charge quantity is little bit higher. For the load bearing walls the charge quantity has to be increased little bit, because the charge confinement increases because of the load onto the walls. So, that is why that has to be considered while the charge quantity is decided for this blasting of walls in demolition blasting. There may be another case where the concrete walls are inside the earth crust, that means the walls are in situ condition. Say suppose this is your surrounding soils, this is your surrounding soil, in this surrounding soil we are having a concrete wall. In that cases we have to drill those wall vertically, because we cannot drill it from the side is already blocked, accessibility is not available. So, in those cases the wall has to be drilled vertically, and you can see this is the wall, around this the soil, around this the soil cover is there. So, you cannot go here to drill this one. So, you have to drill the wall from the surface itself. So, all the drill holes are vertical, and then the blasting has to be carried out. So, as the wall is not very thick, in this case we are having only one row of hole. So, we do not have any burden, only we are having the spacings here. So, this spacing of the holes basically depending on the reinforced wall or not, or non reinforced wall. The drilling is very easy for a non reinforced wall, because you need not to think of the position of the drill hole, but in case of a reinforced wall drilling is very problematic. While the drilling is being carried out, it has been found if that encounter with the reinforcement, then the drilling performance reduces significantly, often the drill bit may be lost. So, basically cross bits are used where the reinforced walls are there to cut the reinforced, cross bits are used, button bits cannot cut the reinforced wall. So, positioning of the hole is very important. It is tried to place the position mouth of the drill hole in such a place, so that it should not struck, say reinforcement must be in between this. Generally if the reinforcement is like this, then it is very difficult to carry out the drilling here. So, that positioning of the hole for a reinforced wall is very important, otherwise the drilling cost may increase significantly. So, this is the charge guideline is given for this condition by Gimeno et al. And again the length criteria remains same, but it it is, if it is a very long wall, length of the wall is very high. If the length of the wall is very high, then we have to go for say little bit large dia drilling, because small dia drilling may deviate for those cases. So, that considerations must be on site, it must be considered, and that decision has to be taken for this particular case. Now, the next part is the blasting of the pillars. So, for pillar blasting, basically it is similar to the beam blasting or wall blasting. The horizontal holes are made either in square or a rectangular pattern. The number of holes and number of rows are basically depending on the dimension of the pillar. If pillar is not very thick, then the single row holes, if it is not a very thick pillar, then single row holes are considered. If it is a very thick pillar, then multiple rows of holes are considered, and in that case the holes are placed at a staggered pattern between the two rows. So, this is the one row, this is another row, and the holes are placed in a staggered pattern between these two rows. So, that is basically ensuring the better charge distribution across the pillars, and that can be initiated and blasted very easily. However, this drill length part remains same, not only for the walls, pillars and slabs, everywhere this 2/3 of the thickness as the whole length is considered, and stemming as the 1/3 of the whole length as the basic guidelines of this one. So, this 2 row is concept is used if the thickness of the pillar is more than 40 centimeter, otherwise single up to 40 centimeter single row hole is considered as the sufficient enough. Depending on the material, type of reinforcement, etc., again the powder factor is varying. And that decision has to be taken on site. Next part is the blasting of the slabs. Basically again the slabs may be reinforced, may be a block concrete one. So, the high energy is required for reinforced concrete. So, the powder factor is higher for the reinforced concrete, blasting of the reinforced concrete, and it is low for the block concrete. For the slab, actually 2 ways it can be made. One is the complete fracturing of the slab, or second one is that the opening a cleft in the slab, and from there we may deploy one excavator to pull out the remaining part, or we can cut the reinforcement using a flame cutter and the rest part can be taken out. So, these are the 2 ways we can excavate or demolish the slabs. And for the slabs, basically vertical drilling is made. Again the length of the hole is kept 2/3 of the thickness of the slab, and spacings and generally again the square pattern is used, burden is equal to spacing, that pattern is used, and the charge quantity is also depending on the type of material and quality of material. So, that is basically considered for the blasting of the slabs. So, this is one example how the different rows are placed and how the staggered pattern is used for the slab, and this is the square pattern is used for the slabs. So, these are the 2 patterns are used. This is one similar slab blasting is shown at this place. And blasting of beams are basically similar to the pillars, only the difference is that beams are placed horizontally. So, the holes are drilled vertically. So, pillars, for the pillars we have to go for the horizontal drilling, for the beams we have to go for the vertical drilling. So, only that is the difference, otherwise the blasting procedure is more or less similar to the pillars, and basically again in this case the charge quantity is depending on the type of material and that is being blasted. So, roof is similar to the slab which is hanged on the pillars, hanged with the support of the pillars. There also procedure of blasting is made as equal to the slab, and the similar to the beam condition is also considered here. So, here you can consider the roof is basically a beam with a higher dimension, that is the width is much larger than the normal beams. So, that is the considerations for the roof, otherwise in both the cases reinforced concretes are used as the material. Now, demolition blasting is basically carried out in three ways. One is the directional blasting with complete fall, second one is the directional blasting with reduced fall, and third one is the collapse blasting. So, the first blasting basically the manual hammering blasting which we have shown you, that was basically one example of. So, you can see this is a blasting of one turbine. So, you can see this is called the directional blasting with complete fall. So, there is nothing made in between, the only the bottom is basically demolished and allow the complete chimney or complete structure has to be fall down by its instability of its own weight, and from there the demolition occurs. So, for directional blasting there are basically two ways. One is that we give excavation at one side, instability at one side, and in that side basically we are allowing, basically the fall of the structure. So, basically you can see here we have drilled and blast this part of the chimney. So, this part of the chimney we have drilled and blast. So, here basically the instability is given. So, here you can see we have taken out this part, and instability is given, that is why the structure has fall down in that particular direction. So, for that basically the drilling is carried out, in this part. This is the rows of the holes, and the length of the holes are 2/3 of the thickness of the structure, and it is blasted so that the rest part is toppled. No drilling and is carried out in the other side of the structure. So, this is the pattern we practice for the demolition of structure in one direction. Here the directional blasting with complete fall also, sometimes this 50% may not sufficient, especially in reinforced concrete etc. In those cases we have to increase this angle up to 120 degree, leaving 120 degree, the rest part that is 240 degree. So, this 240 degree is blasted, leaving 120 degree, and that will allow the fall in that particular direction, because these are the reinforced concrete, high strength concrete. So, that is why it will not allow the demolition of the structures with this 50% portion if it is blasted. So, that is why this is the condition where we have to think the strength of the material in the structure to decide whether how much will be drilled and how much will be blasted to have the complete fall of the structures using the demolition blasting. Now, the second part is the directional blasting with reduced fall. Here the complete structure at one round, say if it is a chimney, the complete part will be blasted and the direction will be given its fall so that it will collapse, and that is why a little bit delay is provided between these blastings. That means, this part will be blasted ahead of this one. So, this is, if it is at 0, then it is at 250 ms. This is at 250 ms. So, there is a little bit time gap between the blasting of this part and this part. So, then what will happen? Actually, let us look back into our old figure. You can see what is happening in this case. We have blasted this one ahead of this one. So, this is blasted, now this is trying to topple down, this is trying to toppling in this particular direction. So, basically by blasting this one, we have given the direction of the remaining portion of the chimney, then we are blasting this one. So, what will happen? This intact part will move in this direction also little bit. So, now it is not moving up to this distance, as now this one is also moving in this direction. So, it will finally coming like this in the floor. So, that is, we are basically reducing the length of the fall by giving a delay in blasting in the remaining part of the chimney. So, that is directional blasting with reduced fall, and this is basically provided by using the explosive with a delayed way. So, we may have subsequent blasting in the other length also. If it is carried out, then we will get the smaller fragment size, we will achieve a smaller fragment pieces by blasting that huge structures. So, that is basically the principle of the reduced fall. When the complete collapse is made, basically here the blasting is carried out, the complete ring, if this is the chimney, first the foundation will be blasted. So, all this part all the holes will be blasted together, there is no time gap between these two. So, then what will happen? The complete bottom will make its instability and without giving any direction of the fall. So, structure will try to collapse in this direction without oscillating its higher elevated part. But what will happen if we have blasted? If we have blasted up to this portion we have blasted, then the remaining structure will become like this. So, it will fall down gradually up to that blasted height. Now, what we would need to do? We need to do then blast the next part. So, this next part has to be blasted. So, this next part has to be blasted. but this blasting has to be carried out in a delayed, may 25 ms or may 50 ms delay, at a 25 ms or 50 ms delay. So, then this will basically reduce the height. So, the next portion will now, come down like this. So, like that way the complete structures will be blasted one by one. So, this is the way the directional blasting is carried out. These are the basic theory of blasting. Suppose there is a structure, we have to fault these structures, demolish these structures giving a directional effect, then the delay has to be, this is the 0th delay, this will be blasted, these are the first delay, these are the second delay, this is the third delay, this is the fourth delay. Like this way, if you are carrying out blasting, this will allow the directional or toppling of the structures at one direction. Similarly, if we need to collapse this one, we have to give the initial delays in the center part, and by this way we will basically giving the delays, and gradually we are allowing the demolition of the structures or the direction of the fall in the center part of the structures. So, this will basically allow the complete collapse of the structures without any directional effect. So, now this is one such collapse blast. So, you can see this is the collapse of the structures without any directional effect, where the center part of the structure is drilled and blasted. This is basically for the steel structures. Steel structure, basically it is not possible to blast them, only it is possible to just disjoint them, and to carry out that, basically huge quantity of explosives has to be placed between the structures. Say if this is a section, the explosive has to be placed at this position, similar to a plaster shooting conditions, and this is 34 in the area of into the area of the average transverse sections of the structures. If it is generally double T beam or simple steel structures, but if the structure is high carbon steel or chain or cable or reinforcing bars, in those cases the charge is almost more than double, that much charge has to be used to disintegrate them. So, that is the requirement. So, this is the formula given, and one example is also given in Gimeno, which is presented here, to how to calculate the charge for that particular type of blasting. So, this is available in the Gimeno. You can see this, the area is decided, the area is decided in centimeter square, because in the previous formula it is given in the centimeter square. So, though the structure dimension is given in mm, so you have to convert the mm to centimeter and find out the area, and multiplying with that 34, it is giving the charge required for the plaster shooting at this I section, in between these I sections. So, that is more or less about the demolition blasting. Thank you.